Chemistry and you are watching Chem Science.
In this video, we will learn what is rate of reaction, methods to calculate the rate of reaction, what is collision theory and how is it related to the rate of reaction, and then factors affecting rate of reaction. Let's start by understanding what is rate. Rate is a measure of the speed of reaction. Now, when we say it's a reaction going on, then we have reactants which gets used up. So when reactants gets used up, that decrease in the concentration, and then when reactants change to the products, the amount of products, that is the concentration of products, increases, that is the products are formed. So let's understand that how can we use this to understand and measure the speed. For example, we can measure that how fast the products are formed, that is the speed of formation of products, or how fast the reactants are used up, that is how far the reactants gets decreased in its concentration or how far they get decreased in the amount. So rate of reaction can be calculated by measuring the amount of reactants that gets used up per unit time. Now unit time, maybe you can measure the time in seconds or you can measure the time in minutes or hours. So unit time is depending upon what type of reaction we are considering and in what amount that is considered, and then the amount of reactants used up is calculated per unit time. Or what we can do is calculate the amount of product produced per unit time. Either of these methods can be used to calculate the rate of reaction. And to calculate that is the change in the reactants or products, what we can do is we can measure any property that changes during the reaction. For example, if a gas is produced during the reaction, then calculate or measure the volume of gas produced per unit time, or calculate the change in the mass of the reaction mixture if a gas is evolved out per unit time again, or calculate the amount of light transmitted during the reaction if there is a change in the reaction conditions or some precipitates are produced or the transparency is affected. Then this method can be used where amount of light transmitted during the reaction is measured per unit time. The next is calculate or measure the change in the pH or electrical conductivity if hydrogen ions are involved or some other ionic equation or ions are involved during the reaction. So if hydrogen ions are involved, we can measure the change in the pH, or some other ions are involved, we can measure the change in the electrical conductivity per unit time. If a reaction mixture faces a change in the color, then also the change in color can be measured during the reaction mixture. Or you use this formula by measuring the above given any of the property and apply this in the formula, that is rate is equal to change in the reactants or products upon time. Now time, as I said, it can be taken in any unit, but if we are measuring any of the above property, the change in that property is considered divided by time in any unit. Now let's see what is collision theory and how does that explain that why the rate of reaction changes during the reaction. Now this is an important point which indicates that during the reaction the rate changes, that is rate is not stable, the rate is not steady, it keeps on changing during the reaction, and this is explained by the collision theory. But let's first understand how this collision theory is related to the rate and the process of occurring of reaction. So the collision theory states that the particles must collide before the reaction can take place. That means that if there is no collision, then no reaction will take place. And suppose even if the particles of the reactants have collided, still all the collisions may not undergo a reaction or may not end up in forming the products. So collisions must be there to a reaction to occur. For example, here if the particles of the reactants are not colliding, no reaction occurs. But if the particles collide, then also there might be a reaction, but it might not be a reaction also. So that depends on some more factors, and let's understand that factors also in this video. And that important factor is activation energy. That is, all the reactants must have the activation energy for a reaction to occur. That is, what is activation energy? That's the minimum amount of energy required by the reactants to undergo a reaction. That means if two or more types of reactants suppose collides, but they don't have enough energy or they don't have the activation energy, then these collisions will not end up in the reaction. But if the collisions have enough energy and they collide with that enough amount of activation energy, then they might end up in forming the product and the reaction will occur. So you can say that during a reaction, all the reactant particles may not have the activation energy, but if few particles have the activation energy, then they will undergo a reaction and form the product. So there might be some reactant particles which does not have activation energy and might not undergo the reaction, but there may be few more particles which undergo the reaction because they have the activation energy. That is the minimum amount of energy required to collide and undergo a reaction to form the product. Now let's understand few more important points about the collision theory considering a reaction. For example, A and B are the reactants and they react to form the product C. Now if this is a reaction, then during a reaction what's going to happen is that the concentration of the reactants will decrease. The concentration of reactants A and B will decrease during the reaction, but the concentration of the products will increase. Why? Because the amount of product gradually increases. So concentration increases, and concentration of reactants, they keep on getting used up, and that's why the concentration of reactants decreases. Now because of that, what happens is that the reaction starts off very quickly. That is, the rate is higher at the start of the reaction because there are greater chance of collisions of the reactant particles because they are present in more amount. The number of reactants are more at the starting of the reaction. So the reaction is faster, the rate is higher at the starting of the reaction. But after some time, the reaction slows down because there are only few reactant particles left over to collide. So let's understand that what happens during the reaction to the concentration of reactants and products in terms of a graph, in terms of a line graph, and say that if the time increases, that is, as the reaction proceeds, the reactants A and B are higher in concentration at the starting of the reaction, and then it decreases during the reaction. For example, here if we have plotted a graph of A, reactant A in concentration terms, then it decreases during the reaction as the reaction proceeds, that is, if the time increases. Same will happen in the case of B also. Now what about the products? Product C will gradually increase in the concentration as more and more product is formed. So this is how you can explain the change in the concentration of reactants and products in terms of a graph of a concentration versus time. Now let's understand that how can we measure the rate with the help of a graph. Suppose if we have taken a curve of product here, then how does measuring the rate can be done with the help of a curve or a graph during a reaction at any given particular of time. And then we will also understand this point, that how does the rate changes during the reaction. As we have already discussed earlier, that initially the rate is highest, that keeps on slowing down as the reaction proceeds. So let's understand how does this happen. Suppose if we have said initial rate, so initial rate, suppose the reaction rate at the time 1 second. Here suppose if we have taken time in seconds. So suppose if this is the point of concentration and time graph where the time is 1. So what are we supposed to do is draw a tangent at the time 1 and then calculate the gradient. Now I am not able to draw the tangent properly, but you can draw it with the scale and then find out the gradient of this tangent. Now if you calculate the gradient of this tangent, you can understand this is 2 point. Now here the concentration is taken, suppose in moles per dm cube unit. So if we calculate the gradient, then it is 2.25. I'm explaining in a very simple term so that you can understand it very easily. Suppose this is 2.25 and the point here, the concentration here is 1.25. So we are going to calculate the gradient as 2.25 minus 1.25 and divide by the change in the time. Now change in time is here, what we have taken is 1.5 approximately to 0.5. Here this is what we are doing, 0.5 and 1. So here it's 1.5 minus 0.5 and this is how we are going to calculate the rate. So if we use this formula, here we have applied change in the products upon the time. Here we have applied this formula, and if we calculate this, we will get 1 divided by 1, that is 1 moles per dm cube per second. This is what we calculate the rate at the time 1 second, because at the time 1 second we had drawn the tangent. Now if we want to draw or calculate the rate at second 3, so draw another tangent at the time 3 seconds. So I am drawing a tangent which is, I'm extending larger because it's very difficult to draw a tangent at such a less steeper point. So I've extended it and made it a longer line, and here we have extended it. So here if you find out the 2 points, this is 2.5 and 3.5. So again if we find out the rate, then rate for the second point is at the time 3 seconds is 3.5 minus 2.5, and the time here will be, say it's 1.5 and it goes to 5 seconds. So division will have time as 5 minus 1.5. Now calculate this. So it's 1 divided by 3.5, which ends up in 0.29 moles per dm cube per second. So now we can see that initially the rate was 1 per unit time and now it's 0.29 units per unit time. So this shows that as the time proceeds, the reaction proceeds, the rate of reaction decreases, and the reason being, we have already discussed that the amount of reactants decreases, the concentration of reactants decreases, and because of that the collisions, you can use the word successful collisions decreases, because there are less chances of reactants to collide as the particles of reactants have decreased and the products have increased. And this just does not imply to one reaction, it implies to all the types of reaction. That is, the rate is highest at the starting of reaction and it decreases over time. So if we think in terms of collisions, then we can definitely vary the rate also. So according to the collision theory, to increase the rate of reaction, we might need certain things. For example, more frequent collisions. So number of collisions per unit time should increase. So increasing the speed of particles will increase the collision frequency, Or if we have higher number of particles, then also the frequency of collision, that is the number of collisions per unit time, is going to increase. Another factor is that if we have more successful collisions, now successful collisions means the collisions which end up in the product. That is, as we have already seen earlier, that all the collisions does not turn up into the products. So there are the collisions which are successful and the reaction occurs and forms the products. Such collisions are called successful collisions. So to increase the successful collisions, we can give particles more energy so that enough particles have the activation energy to undergo the reaction, or we can decrease the lower the activation energy so that more number of particles can undergo the successful collision and end up in the product. So there are two factors: increase the frequency of the collision or increase the number of successful collisions. Now we can understand one more point here in this video is that there are certain factors which can affect the rate. That is, if we change these factors, we can change the rate also. So what are these factors? First and foremost point, the factor which can affect the rate is the surface area of the solid particles of the reactants. So if we increase the surface area of the solid particles of reactants, then the rate might increase. If we increase the temperature of the reaction mixture, that will also affect the rate. Add a catalyst to increase the rate, or increase the concentration of the reactants, that is again going to increase the rate. Increase the pressure of the reaction mixture if the gases are involved in the reaction, then increasing the pressure will definitely affect the rate, that is increase the rate. If there is a reaction where the sunlight affects, that is if it's a photochemical reaction, then the sunlight or the light, presence of light, will also affect the rate. So in the upcoming videos, we will understand this each and every factor in detail and understand that how the change in this factor is going to affect the rate or is going to increase or decrease the rate.